Okay, so in order to finish up our science lesson from today, some of our classes are a little further ahead than others, so you need to find where we left off with your homeroom and then pick up the video there. But I will expect when I collect your books here in a couple weeks that all of your information is filled out in your book that I'm going to be sharing on this video as well as throughout all the rest of the classes. So all the classes we got to the point where we talked about on page 159 in our books, filling in the information about the boards with the circles hanging on them being positive and negative, showing attractions and repelling. So attractions, once again, was the two to the far right because they're drawn together, and repelling, they're pushing away. So we know that if they're the same, opposites are going to attract, but if they're the same, they're going to repel and they're going to push away. So where most of the classes didn't get, then we talked about looking at the different balloons on page 161. On 161, the very first sentence up under where it says, how does charge build up? It says, most objects have no overall charge. That's an important piece of information that I pointed out to at least one of the classes that we got that far that you need to understand. Not everything has a positive charge. Most things don't have a charge at all. It's not that they don't have any charge, but the particles even themselves out. If their positives and negatives have the same amount, then we have a neutral charge. So when we look at the diagram that they're showing you here and the graphic sources with the girl and the balloon, that's what they're pointing out on the very first balloon. And then we have 3 positive and 3 negative. Well, as I talked to a couple of different classes, if I take 3 steps forward and then 3 steps back, I end up in a neutral position. I haven't gone anywhere. With 3 positive and 3 negative charges on my balloon, I have a neutrally charged balloon. So the information I should be circling on the first one is that the balloon is not charged because it cancels itself out. The balloon neither attracts or repels the girl's hair. And then when we follow down in the graphic source, we see in step 2, she's going to rub the balloon on the sleeve of her wool sweater. That's going to add things to the balloon. And it begins telling us what is being added. It says the rubbing the balloon allows more electrons to move onto the balloon. When we talk about electrons, once again, we're talking about negative charged particles. So on the second one, we see that rubbing the balloon allows more electrons to move onto the balloon. The balloon is now negatively charged. And then what you need to do is you need to fill in the balloon with positives and negatives. Now, when we get closer to the end of the section, we talk about the law of conservation of charges. Just like energy, I can't lose energy, I can't gain energy, I can only exchange it. So I can't create it and I can't destroy it. So I have to include my original 3 positives, or protons, and my original 3 negatives, or electrons. But then, because I rubbed it on my sleeve, I'm going to add several more. Add 4 or 5 different electrons onto that balloon. When there are more electrons than there are protons, that's how I know it's a negatively charged item. In this case, it would be the balloon. Then she lifts it up into the same distance as before, where the hair didn't move because there was no charge. Well, now we're going to have an attraction. Why is there an attraction? Because her hair has to be what? Her hair has to be a positive charge. Because if the balloon is a negative charge and there's an attraction between them, therefore the hair is moving through the balloon, we know it has to have positive charges in the hair. Then I'm going to show that my electrons are going to move over to the side where the hair is attracted to. So as the hair comes down in positive charges, then the electrons with the negative charges of the balloon would be joining together, which is going to cause them to be attracted to one another, because opposites attract. When we continue on then in the book, we talk about 3 different ways in which our charging can take place. So you should have these pages on 162 and 163, and we're specifically looking at A, B, and C down here at the bottom corner of 163. Now we talked about friction already, and we know that friction is the rubbing of items together. So when we talk about adding charges through friction, it's happening because we're rubbing something on something else. So what we talked about today in class was rubbing our feet when we have socks on onto the carpet. I'm going to add more negative particles into myself so I'm going to add more electrons, and then when I go and touch the handle, or I touch someone's ear or whatever, then I have that static electric shock. It's because I built up my electrons and I touch something that's positively charged, then there's that sudden exchange of electricity. The second one then is the conduction. And when we talk about conduction, we're talking about giving that energy because they touch. So if I, once again, have increased my electrons and I'm negatively charged and I go and I touch something, that is a direct exchange through that interaction of one item touching another item, which is going to cause it to go over. So conduction is when they touch, then I have a sharing of particles. So notice in this picture, I have a sharing of particles with this globe and her hair, because they're touching one another and there's an even exchange going on. And then in the last two, we have induction and polarization. Induction is the objects that just simply do not touch. So there's an exchange without a touching going on. If I have a really strong magnet and I move it close to a piece of metal, that magnet is going to be strong enough to pull it and cause it to move. When my particles are in a high amount and they are going to be attracted to the opposite charge, if it's in a high amount, doesn't actually have to touch. That exchange is going to happen. When we go on to page 164 then, on 164, we talk about static discharge and an exchange that's going on there. Well, one of the things that we talk about in question 1, it says, anyone who works with computers has to be aware of static discharge. Even small discharges can damage electrical equipment. So when we talk about static discharge, then at the top, it gives us different examples of how static discharge, or that electric shock, that static shock, is going to take place. From us touching one item or another, or we are around things that are going to build up static electricity. So if you are working with computers and small amounts of static electricity will ruin a computer chip, then we have to make sure that we do something to protect from it. If you work in a computer lab, you have specific types of clothes that you can wear, and a lot of times then they have coverings that they have to wear, but they also have insulators on the bottom of their shoes and wrapped around their shoes, so there isn't any kind of static electricity that's being built up in that room. They also flood that room with moisture to keep all the electrons from being able to build up in the room and causing problems. But if you're working at home trying to fix your own computer, then some of the things you would want to avoid, two of them that I am going to list. One would be your furry animals. If you have animals with long hair, especially cats, I do the same thing with my cat. As you pet it, you can hear the snap, crackle, pop of that static change as your hand goes down their fur. Another one that you have to watch out for is the clothing that you would wear. So if you have wool on, then you're going to be building up that electrical charge. So wools and scarves and things like that, you have to make sure that you're careful around if you're dealing with your computer. The second thing it says, what should the conditions of the room be like that you're working in with a computer? And that's where you don't want it to be super dry. If it's super dry, those electrons are really going to be in a high amount, which is going to increase the possibility of having an electrical discharge. So we have to make sure that it's not dry. So we have to add moisture into the air. So a lot of times, especially in the wintertime, you'll see where people are going to have humidifiers in their home or in their particular room where they're sleeping. When we were younger, we just put a pot of water on our wood-burning stove and we let it boil out. And we constantly refilled it. It kept the moisture inside the house, kept those electrons from building up. But you can get all sorts of humidifiers out on the market. If you work in a company, for a company like this, you're going to have a humidifier in the building and in the heating and air ducts that keep that moisture constantly going and reducing those electrons from building up. The other thing it talks about on these, at the top or at the bottom of these two pages, 164 and 165, is about the idea of lightning. Now this isn't the same picture that's inside of your book, but it gives you the same idea. We're talking about how protons and electrons are added up inside of our clouds up in our atmosphere. Well, the protons rise. They're going to be on top of the clouds where the electrons are going to be down below. And as our clouds get more and more condense, they get heavier and they lower down in atmosphere. And when they get closer down to the ground in atmosphere, our ground is also covered in protons or positive charges. And that's when the opposites are going to attract, and that's what causes lightning. So you have circles on your clouds on these 2 pages that you need to fill in. At the top of the cloud should all be positive signs, because that's where your protons are located in the clouds or in the condensation. And then your electrons are down below in those storm clouds, because they're also attracted to the ground. And then once again, as we get closer to the ground, where it's all positive charge also, the closer you get, the higher pull there is for that attraction to happen, and then that's when your lightning strikes begin to happen. The last thing that we look at then are the questions that are being asked on page 165. On 1A it says, what happens to an object's atoms when the object becomes positively charged? Well, when it becomes positively charged, the objects are going to lose their electrons. So it doesn't mean that they suddenly disappear and they're destroyed. It means that they are exchanged with something else. It's going to give off the electrons. If I have rubbed my feet with wool and I go and I touch something, I build up my electrons, but then I touch something that's positive, it absorbs those electrons out of me, so I become positively charged once again by losing my electrons. And B says, explain how you could use a piece of silk and a glass rod to attract a stream of tap water. This is an experiment that I used to be able to do when I had the science lab. You can take that glass rod and you can become negatively charged, by using the silk. So if I take the silk rod and I constantly rub and polish that piece of glass, the more electrons are going to build up on it. There's positives or protons in the water. So when there's a stream of water coming down, if I have a negatively charged rod, then it's going to cause my water to actually bend towards the rod as it passes it. So I can actually cause the water to move back and forth when I use that rod without actually touching the water. So what you need to fill in is that by rubbing the silk on the glass rod, friction charges the glass. The glass rod would then attract the water by polarization. Polarization is by rubbing on something, causing a friction, but increasing such a large power of protons and neutrons, protons and electrons, that it causes the exchange to happen without them touching, just like conduction. So that's all the information that you need to fill in inside of your book. So once you have it filled in, then you can go to my substitute teacher for the day and get your assignment. Your assignment is due tomorrow.